All right, so welcome everyone to today's live stream. I will be your host and I will be your physics teacher for the rest of the semester. And good afternoon for you. Hello, everyone. So first of all, before we start, let's check the quality of broadcast. So on the scale of 1 to 10, how is the broadcast? Is my video fine? Is my audio fine? Type in the number in the chat. Just let me know if it is all right. Hello. Okay. Before moving on, so I hope you're doing fine, everyone. Hello, Mihir Chaudhary. Hello, and let's see how it's going. So before we begin, let's check the quality of broadcast. 10. All right. Okay then. Okay. Then let's move on. Everything fine. Everything is great. Then let's move on and see what's going on. Let me just see. Yeah. So first of all, how is the preparation, everyone? I hope you're doing fine, and I hope you're not that stressed out. Let's see. Hello, Abhinav. Hello. I hope you're not stressed out about the exam. So how is the preparation going? How is the JEE journey going on for you? Tell me. Everything good? Are you anything? Is there anything that you would like to share? Let's see. There are a lot of people in the chat today. 3. Oh, that's perfect. That's perfect, Pratisha. One. Well, no problem then too, because we are here to help, right? That is why we are here. Let's see. Hello, BSSE. Hi. Nice name. Okay, so let's not waste any further time and let's move on, right? Let's see. So a little bit about me. I will be teaching you physics, of course. I gave JEE a few years ago. Nothing going good, sir. Don't worry, it will go good now. I am there for you. So I gave JEE a few years ago and received more than 99 percentile in both physics and chemistry. Okay, so the font is a little bit messed up. I see that. I had more than 250. I'm gonna explain it to you. Don't worry. I had more than 250 marks in my JEE mains exam. So I'm currently pursuing my interest in microsystems and UAV, basically electronics and communication. And I have written 2 papers which have been gone to publication. And I'm driven to use technology to end human suffering. So that's me. If there's anything you'd like to ask about me, then that would be great. But let's see. Hello, team. Karthik and Shiv-Kumar. Damn, I'm seeing that you're quite angry about this preparation. Well, we're here to fix that, right? So I will be teaching you gravitation. So today's topic will be, of course, the introduction to gravitation. I will be starting from the. I will be starting by introducing you about gravitation is, and I will do the course in continuity with your course in class 9th. You might have studied gravitation in class 9th, and we're gonna continue from that. So our journey will start where we ended class 9th. So let's move on and let's begin the course, shall we? All right. So this is gravitation. So this is the first class. Of course, there will be 2 more classes of gravitation. So be sure to follow us and basically to get free classes of gravitation. So let's move on and not waste any further time. Okay, so let's start. What is gravitation? Okay, so I'm about to write some things. And remember, whatever I write on the screen, you should note that down too. Hello, Jayan Gupta. Hello. You should all note down everything which I write, because these are the notes which will be useful. I have given JEE myself and I had a great score. So don't worry, everything will go perfect for you. Let's begin and start a new chapter in your life or a fresh page, and let's go. So what is gravitation? Let's talk about it for a minute. So gravitation is a force of attraction. You might have all heard of it. You might have done questions of it, or you not might, but you must have done questions of it in class 9. So this is a very interesting topic, right? It is one of the easiest topics in the physics, and also one of the most scoring one, because every question that you will get from gravitation in both JEE Mains and JEE Advanced, you will crack it easily, because there is nothing difficult about gravitation. There are basically 3 or 4 concepts which are important, and they will just they will make your journey very easy if you understand it. And the questions are asked from only 3 or 4 topics with just manipulation and variation, and you will know how to handle it. I will tell you the techniques on how to handle those. I will tell you how to cope up with the stress of JEE exam, because it's a 2 years preparation, and our students have to invest a lot of time in studying. So let's begin, right? Okay. So what is gravitation? First of all, it is a force of attraction which binds our universe together. Meher. Damn. Yeah. Great. Sorry, I'm a little bit under the weather, but yeah, I understand the feeling. Yeah, Anwar, I have to talk in English because many students are from different parts of India, because they are not able to speak Hindi, right? Like, Hindi is not spoken all around the India. All right, let's move on. So it is, let's write, it is the force of attraction, force of attraction, attraction which binds our universe together, which which binds our universe together, binds our universe together. That's the first point, and that is the point which you should write. And keep this in mind that these points will form your basics and the foundation of your journey throughout JEE. And the force which binds our universe together, of course, because the universe is bounded together, right? Together, together. So this is the first point. This is a force which keeps our galaxies together, our planets together, our solar system together. Basically, the Earth in a round shape or a spherical shape. That's this force. And let's move on and let's see what is the nature of this force. That is, it is always attractive in nature. You must have never seen any gravitational force which might repel each other. They always attract each other. For example, Sun and Earth, they do not repel each other. They always attract each other. So this is always attractive in nature. I mean that is one of the reasons that we are binded together, because this force attracts each other. So it is always attractive in nature. It is always attractive, attractive, attractive in nature, in nature, right? Yep. It is a center force. Yep, it is. And if you have any questions in the middle of class, please feel free to ask me. I would be happy to resolve them. Because you guys are my younger brothers and sisters, and it's an honor for me to teach you, and it would be an honor for me to answer your queries. So let's move on, right? So every object with mass will experience it. Third point: every object with mass will experience it. Basically, around us has mass, except maybe light, right? So every object with mass will experience it. That's the thing. Yep, every object with 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 mass will experience it. Yeah, will experience it. Experience it, right? So that's it for gravitation, and of course it's also a central force. But I'm going to explain what central force is and how it acts. We usually say that it acts on the center, but there's a reason that it acts on the center. It acts basically on the center of mass. So that is the center of an object most of the time when we're talking about it. But sometimes maybe the JEE Advanced might ask question in which the center of mass is at someplace else, right? So we should keep that in mind, that it acts on the center of mass. So this is the introduction to gravitation, and let's move on to the next topic of this chapter, which will be Newton's law of gravitation. So Let's read what it does mean. Newton's law of universal gravitation is usually stated as that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses. So keep this in mind, directly proportional. What does it say? Let me just use another ink color. Let's use highlighter. Directly proportional to the product of their masses. So this is a very important point. And inversely proportional to the square of the distance between their centers, right? Of course, this is, as you said, that it is a center force, so it will act on its center, but it should be center of mass. But it is clearly understood that would be mean center of mass when we talk about this. So it is directly proportional to the product of the masses. I'm about to derive a formula which you must have seen in class 9, but it is necessary to know how it is derived and which law of Newton derives it. So we have the force will be directly proportional to, okay, so what is happening? Okay, let me just see. Okay. Wait a minute. Okay. All right. Okay. Something is clearly not working. My stylus, it has lost its touch. Oh, wait, let me figure it out. What is happening? Okay. Options, automatic ink with pen. Yeah. Okay. Let's see. There is something very sinister going on here. So, is my highlighter working? Yes, it is working, but my stylus is not working. Is there anything? Yup, there's something wrong with the stylus. Huh. Pretty interesting. Let's see. So, all right. So, just a minute. We will need some assistant. All right. Let's plug it back in and let's see if it is working fine. It is not. Oh, this is a very interesting thing which is happening. Okay. Let's see. Let me just. How about let me just open the slide again, right? Start. Okay, let's start the slide again, right? Let's see. Okay, let's see if the ink is working. Yeah, it is working. Perfect. So, yeah, sorry for the inconvenience, students, and let's move on and without wasting any further time. Okay, so what does it say? Let me just use the highlighter again. How about I do not use the highlighter, right? It is directly proportional to the square product of the masses and inversely proportional to the square of the distance between their centers, right? That is the Newton's law of universal gravitation. Hello, sir. Hello, Devanpal. I might have seen you before, and it's nice to have you here. So the force which will be experienced by a particle, will depend upon it is directly proportional to the product of their masses. F is proportional to the product of their masses m1 into m2. That is our equation. That is where we are. And F is, we should say proportional, right? The sign of proportionality is like this. Yeah. And F is also inversely proportional. That means it is like this. It is inversely proportional to 1 by r square. The square inversely proportional to the square of the distance between the center. So F is proportional to m1 into m2. F is proportional to 1 by r square. So what is F proportional to? So we can say that F is proportional to m1, m2 by r square, right? And when we remove the when we remove the sign of proportionality, we introduce a constant. So we will introduce a constant here F equals G M1 lag. Yeah, F equals to G M1 M2 by R squared. I don't think there might be any lag because I can see the screen. But if there is, please let me know. And thank you for sharing the screen. So F is proportional to G M1 M2 by R square. Let's write it in a more better manner. Let me, yep. F is proportional to G M1 M2 upon R square. So this is our equation. And we should keep this in mind that this is Newton's law of gravitation. Every other equation will be derived from it except Kepler's law, maybe. So let's see. So G, what is G? G is universal gravitational constant. G is equal to 6.67 into 10 raised to power minus 11 Newton meter square upon kg square. This is our gravitational constant, universal gravitational constant basically. So let's see, what does it mean? Universal gravitational oh god, it is clearly not visible here. So let me write it down over some place else. Yeah, how about here? So G will be universal universal gravitational constant. Gravitation. Okay, another mistake. Sorry, students. And let's move on. Universal gravitational constant. Right? Keep this in mind. This thing will be constant throughout the journey. And in every chapter, this will be considered as a constant, right? So let's move on to another topic, a new topic, which is acceleration due to gravity on Earth. Okay, so this will be acceleration due to gravity on Earth. Let's see. We need to find the acceleration which is caused by the gravitational force to an object. So the gravitational force on an object creates an acceleration. Understand what I'm saying? So force creates an acceleration. That is what we are saying, right? So what will be the force exerted by the gravity? Force exerted by the gravitational force exerted by gravity on an object, right? So force which is exerted by the Earth on an object will be equal to G M, which is the mass of Earth, and small m, which is the mass of an object. All right. If you have anything to ask, feel free and go ahead, ask anything. I will be able to answer it. So, and I will try my best if I'm not. So let's move on and see that it will be equal to the force exerted by the Earth on the object. Keep these words in mind. Exerted by the Earth on the object will be equal to Gm, capital M, small m by R square, right? In this case, the force exerted by, well, in every case, the force exerted by the object on Earth will be the same. But we need to keep in mind on about which force are we talking about. We are talking about the force on the object, not on the Earth, because we need to find the acceleration of the object, not on the Earth, right? So Gmm by R square will be the force on the object, right? Let me just write it down in a better manner. Force on the object. Yeah, so this will be the force on the object. Now what is acceleration? So let's talk about what acceleration is. So acceleration will be by Newton's second law. So let's talk about Newton's second law, the most easiest one. Basically F equals ma. Newton's second law. By Newton's second law, acceleration acceleration, let me write it down in full. Acceleration will be equal to force upon mass, right? Mass. So it's like this: A equals F by M, right? So basically, I have written F equals MA, sorry, F equals MA in this form. Okay, nothing new, nothing to worry about, and everything is fine. So A is equal to F by M. So we need to find the acceleration of the object, right? So if we find the acceleration of the object, that will be A shall be equal to, what is the force? Gm small m by r square upon small m, because we are finding the acceleration of the object. This is the mass of the object. This will cancel out, and this will be equal to Gm by r square. And we can also call this G, because just giving it another term, nothing new. Our problem solved. We just calling it G, which is the gravitational constant, gravity, basically the acceleration due to gravity on Earth, which will be constant, which will be considered constant in some cases in which it is specified. So that will be equal to G equal Gm by r square. This will be the acceleration due to gravity on Earth. So this whole thing, hello, Mr. Chaudhary, welcome back, welcome back. It's nice to have you back. And I was just talking about acceleration due to gravity on Earth. This is basically somewhat a revision from what you have studied in ninth. But after this topic, what is gonna start will help you in understanding what do we mean by when I say gravitation, and what do we mean when I say variation in acceleration, right? So this is just a proper revision with giving you strong concepts, so that you will build a strong foundation on what is going to happen, right? So G equals Gm by r square. So this whole thing is constant. Gravitational constant is, of course, by the name constant. Mass of the Earth is constant. Well, yeah, it is. It will remain constant unless something happens. Basically, the Earth explodes, but which is unlikely. Radius will remain constant. Highly unlikely that it will change. So this whole thing is, I mean, has been constant since time immemorial. So what is the value of G? So G comes out to be 9.81 meter per second square. So that is how we have our value of G, the value of gravitation, right? So this is your Gm by r square. And now let's move on and see. Wait, by the way, before moving on, let me just tell you something. So we have a Telegram channel, by the way. You can scan the link and join it. So on that Telegram channel, we offer you variation like height, depth, and rotation. Yep. Damn, yeah. So I'm gonna tell you about that. So basically, on our Telegram channel, we have notification about free classes, free PDF material, and announcements, and there are many discounts and prices on our upcoming courses. Right now we're conducting a giveaway in which 10 random students from our Telegram group will be chosen, and they will be given free course for a month. So make sure to join the Telegram so you don't miss out anything. It's a nice place to be. Seem or to easy calculation we considered 10. Yeah. So G equals 9.81 meter square for the ease in calculation, right? So that calculation remain easy. We consider it 10, because 9.8 is very difficult to solve sometimes when you're dealing with higher numbers. And also, if you're talking about bigger quantities, I mean numericals which gets very big, like in JEE Advanced and JEE Mains, we consider it 10 sometimes, right? If the shoe fits, wear it basically. So let's check about the variation in acceleration due to gravity, and be sure to join the Telegram channel. It's a great place. All right. Okay. So variation in acceleration due to gravity at height h. So now the real concept of class 11 begins. Right. All right, Meher Chaudhary. Let's move on. All right, and talk about what is happening with our dear acceleration. Let's see where this is the pen. Yeah, here's the pen with me. Okay. So at height h above the surface of Earth, what will be the force? Force of acceleration, force exerted by Earth on the object will be G(m)(m) by R plus H squared, right? Nothing new is happening. You just change the distance between the centers, in which the distance is R, basically the radius of Earth, and H, the height above the surface of Earth. So that is R plus H. So what will be the acceleration? What will be the acceleration? Acceleration will be, let's move on. A would be equal to F by M. Like we always say, we should always follow the procedure and the formula, and we will never be wrong in our exams. Take it from as a personal experience. So A equals F by M, right? So what will be A? What will be A? A shall be equal to Gm by R plus H squared. Okay. Now this you have basically we can call it G dash. That is the variation of G, basically nothing new. It's just a term. So G dash equal Gm by R plus H. Your question has the variation and acceleration due to gravity has been solved here. We have found out what is happening. So basically the answer is solved, but for simplification, we're gonna multiply it by R square on numerator and R square on denominator. Nothing has changed. We just multiply it by basically 1, right? Multiplying by 1 just because that does not change anything. So we multiplied that, then we're gonna write it as this: Gm by R square into R by R plus H square, right? So this is G dash. Now, so when syllabus will complete? Syllabus will complete. Okay, so we are right now conducting the syllabus of JEE. We're targeting the JEE Advanced, which will happen in May and June. So syllabus will complete in its own pace. Completing the syllabus is not important as much as understanding it, because if you have understanding of basically 50% syllabus, then you will score around more than 150 marks. Like that is the criteria. Basically, they asked around 60% question from class 11th. So even if you have proficiency over 50% of syllabus over class 11th, then that would give you what is the 60% of 300? I think the exam is 300, right? Because when I gave it was like 360. So it will give you around, let's see, what will be 30, 60% of 30? 180 marks. 180 marks. It will give you more than 180 marks. So that is great. So syllabus will complete in its own pace. Don't worry about that. But what you need to worry about is completing the course. You completed the course on your own. That is, you need to understand every topic which is happening, so that when you give the exam, nothing will be new to you. It will be like walk in a park or eating a piece of cake. Nothing will be new to you. It's like riding a cycle, right? Okay, so G dash equal to Gm by R square. Let's not divert from the topic. Let's not be distracted. G dash equal to Gm by R square. We multiplied R square in numerator and denominator, and this will be the term which will remain. So what will be this term? What will this term be called? Remember, this term was called G, and we have that as constant. So we're gonna write G in our formula. So R by R plus H square, right? Yep. Yes. So we have our formula finally. So this is the greatest formula that we have found out. Right. So let's check a few things. Let's see if this formula works. Because, I mean, why are we going to test it if it's not going to work? So let's put H is equal to 0. Suppose the object is at the surface of Earth. Then G dash shall be equal to G R upon R plus 0, basically square, and this will cancel out. So that means G dash will be equal to G if H equals 0. Okay, so we have H equals 0, and I'm gonna remove this. You can do it on your own. It's like putting values in the formula and getting the answer. Nothing new. So suppose H is so big, that means it is so far away from Earth that we cannot even see it. Of course, we cannot even see it. It is so far away that let's say it is at infinity. Suppose it is at infinity. Suppose, right? If h equals infinity, okay. If h equals infinity, Suppose h equals infinity. So g dash equals g r upon r plus infinity, right? So anything plus infinity will be basically infinity, nothing new. So this will be infinity. If the denominator is infinity, then the whole thing will turn into zero. So g dash will then be zero. That means it will experience no effect from Earth. That means the force of attraction, force of gravitation, that means the variation in acceleration due to gravity or whatever you call it, g dash will be equal to zero. So this is very interesting thing. Just keep these results in mind. Write down everything which I write, because these are my notes, and these are the notes through which I was able to score basically very good, great marks. So let's move on to next topic, which is below the surface of Earth. So this is very interesting because this is gonna take a time, and if you know how to derive a formula, then you don't even need to memorize it. But I would recommend memorizing it because it helps in JEE Mains in advance. But you don't need to memorize it if you know the formula, right? So let's see below the surface of Earth. So suppose we have reached depth d, and this is the new radius of the Earth, which is r dash, which shall be equal to r minus d. Of course, r is the radius of the Earth, right? This is center of the Earth and actual surface of the Earth. Suppose you start digging, and you dig day and night, like day and night continuously, and then you reached a depth d, and you experience that, hey, you are lighter. Something is wrong. Something is happening which is not supposed to happen. That means your weight is getting reduced. Maybe that's a new weight loss technique, by the way. But suppose something is happening, and how would you figure it out? How would you figure out what is happening? So let's see what is going on. First of all, let me tell you something. Outer surface of the Earth, that means outer Earth, the part which is excluded, will not have any effect because it will act as a shell. So let's write it down because this concept is very important. Outer outer surface will not have have any effect because it will act as a shell. Effect because it will act act let me write it down in a better way. It will, if you do not understand something on the screen, just let me know. I'm a NEET aspirant. Okay, Pankaj, well, that's great because I mean the physics is same for both of us, right? So we also have NEET courses, by the way. This is a JEE course, but we also teach NEET lessons. There are various faculties which do that. So, but you can benefit from this class too. The physics is mostly the same. In JEE Mains and Advanced, I've seen that it is somewhat difficult, more difficult, but don't worry about that. If you know the difficult thing, then you must know the easy thing, right? That's obvious. So it will have an effect because it will act as a shell, right? Yep, it will act as a shell. Let's see. Okay. So what will be our acceleration due to gravity? Suppose, assuming Earth has uniform density. First assumption, assumption. Let's make an assumption. Assumption: Earth has uniform density, right? We are thinking that every part of Earth has the same density as it has on the surface, but this is not correct actually because the core is made of molten lava or heavy metals, or I don't know, maybe the metals. Yeah, basically it is a red hot fireball, and then there is mantle, and then there is crust, right? So every part of the Earth has different density, but this is for solving the questions. We need to get into IIT JEE. We need to crack JEE Advanced and get into IIT, or basically a better college like NIT, DTU. But We need to keep in mind that we just need to solve the question and not waste our time in figuring out what is what and what is happening. Let's just assume what NCERT is saying us to assume. Earth is of uniform density. Uniform density. Density. Okay, let's write it down in a better manner because that was clearly not visible even to me. In uniform density. If you have any trouble reading or something, just please let me know. I would be happy to help. And okay, that is our assumption, by the way. Earth is of uniform density, that is the density of the Earth can be written as basically let me write it as rho because that term has not been used. So let's just say rho is equal to m mass of Earth upon 4 by 3 pi r cube. That is the density of the Earth. So what will be the mass of this center of the Earth? Mass of the remaining Earth, that is m dash, m dash shall be equal to m dash shall be equal to m dash shall be equal to rho into v dash, the remaining volume, right? Basically density into volume, that is mass, that is, these are the concepts from class 10, don't worry. So m dash will be equal to uh, rho. So what is rho? Sorry, let me just write down the value of rho. So what is rho? Rho is m upon 4 by 3 pi r cube. And what is the volume of inside portion? That is, what will be the volume of inside portion? That will be equal to 4 by 3 pi r dash cube. Sorry, yeah, r dash, this one. So let's just 4 by 3 pi will cancel out, 4 by 3 pi will cancel out. And what will remain is m r dash upon r, basically r dash upon r cube. And what will be the r dash? R dash will be r old dear r minus d, upon r cube. That will be the m dash. So I hope you might have written everything. If not, just let me know. Type 1 in the chat if you have written everything. I will remove this. I will give you basically 20 seconds. Yeah, I will give you 15 seconds to type. Then I'm going to remove everything. So because I need to explain to you what is happening, and it will take some more portion of this board. So 3, 2, 1, anything. Yep. Okay. So I am removing this. Okay. Okay. Yep. Okay. Then I'll remove it. Basically, that was enough time, and we will screenshot. Yeah, you can take the screenshot, by the way, if you just rewind the track and you can take the screenshot. So basically, what I've removed is that the outer surface will not have any effect because it will act as a shell. That is perfect assumption. Earth is of uniform density. That is an assumption. Nothing to worry about that. Yeah, okay. And this will be the density. Rho is equal to m by 4 by 3 pi r cube. And m dash will be rho into v dash. This will be our m dash. So our m dash will come out to be, let's just move to the results, right? Okay. Okay, damn, my Mihir Chaudhary is having way too much. That's great. That's great. That's great. M dash, that's value be equal to m r minus d by r whole cube, right? So what will be the gravitation? What will be the force of gravitation? Now, well, we will talk about force first, and then we will talk about what is happening with acceleration, right? So force shall be equal to gm, again, gm dash m small m by r minus d whole square. I hope everything is perfect here because we can see that the distance between the center has changed because we have dig further down. And let's see what it means. So g, let's write m dash, m basically small m. I'm gonna write this down later. R minus d cube, right? And r minus d square into, let's say, r square into r. You will know why I said it r square, because this r square will come in handy. So we're gonna cancel r minus d square with r minus d cube, and what will remain is r minus d. And this gm by r square, right? So let's write it down in a better manner. Gm by r square uh, into m into r minus d by r. This will be our force. Now what will be our acceleration? A shall be equal to F by m, right? So A shall be equal to Gm by r square uh, into m into basically 1 minus d by r, right? I have done nothing. I just divided by r on both terms upon m. So this will cancel out. What will this be? What will this be? This will become g. So what will remain will be, that means a, that will be equal to basically g dash, right? That will be equal to g1 minus d by r. So take a screenshot. I am giving you basically 10 seconds for you to take a screenshot, because I'm gonna move forward after this. So that will be very necessary for us, because of course that is how life works. We need to move forward. 10 seconds has passed by, and let's remove this, and let's just focus on the result. Uh, 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 let's move on. Gravitation is a wonderful topic, by the way. If you solve it perfectly, then you might have interest in other topics. And the thing with the physics is that if you have interest, if you have a strong base, like let's say till the chapter gravitation, right, or rotation, basically rotation. My teacher used to say that rotation will be a chapter which will make or break a student. That means a student will start to hate physics, or he will start to love physics after that. Right, done, perfect, perfect, perfect. So that is our physics basically. If you have a strong foundation, you will love it. If you have a weak foundation, that means if you do not study, I mean, in the first 7 8 chapters, then you will start to hate it with all your heart. But I would not advise hating physics, because this will be one of the most scoring after chemistry mostly. But yeah, don't hate physics. I mean, I remember I had like more than 100 marks in physics. So this was the most scoring subject for me. So g dash will be equal to g minus g 1 minus d by r. Now what will be the, so this is g dash below the earth, right? And suppose, let's say, g double dash outside the earth. That means, sorry, this is g dash below the earth, and what is going to be above the earth? Let's see. Above the earth we have g r upon r plus h square. So we have g, let me turn on focus mode. Yeah, g r plus h square. H square. Oh god, not something which is great. Yeah. So I didn't understand the concept of superposition. Okay. Let me just explain it to you. R square. Okay. So basically, the concept of superposition in the gravitation, uh, it says that the forces will be basically, it talks about the summing of forces, and that due to superposition, this thing will act as a shell, right? So let me just finish this concept, and then I'm going to teach you about superposition. So let's just finish this concept, and let me just tell you what I'm about to tell you, because let's not lose our focus and lose our flow right now. I will tell you about superposition. So what will be the concept? I'm telling you what will be the variation of acceleration due to gravity, and variation of gravity with depth to height, right? Suppose suppose, yeah, suppose you start from center of the earth and then you reach till infinity. So when you start from the center of the earth, the basically the depth or the height from the center of the earth, you guess the distance, right? That is the r will be, let's just say, let me just you know make this graph. uh yeah yeah yeah, let me make this graph. Yeah, so huh let's see this graph will look something like this, right? And then something like this. Not exactly, okay, because you need to figure out what is happening, and the curvature will be somewhat near the earth, right? So this is r, and let's say this is g dash, and this will be below the earth, right? This part will be below the earth, and this part will be above, basically above the surface. Above the surface, excuse me, above the surface. So can you tell me what this line represents? What will be this point called? Think about it, and I'm giving you basically 20 seconds to think about it. So let me just drink water in the middle, in the meanwhile. So, by the way, superposition, yeah, I can tell you about the superposition in meanwhile. So what superposition means? It is basically about the gravitational field. So when we will talk about gravitational field in the next class. So it is basically like electric field, but with gravitation. So when we talk about superposition, when we say that all of the sum of vector forces at a certain point will be, yeah, okay, sorry, the sum of vector forces. Let's see, the net gravitational field at a point will be the vector sum of the gravitational field at a point due to different source. Suppose let's just say let me be like this. Yeah. So this thing helps in solving questions like this. Let's you take a screenshot. I will remove this. Right. By the way, this point is called R. That means the surface of the Earth. When we reach the surface of the Earth, the gravitation force is at the maximum. So let's just remove this and talk about what superposition is. By the way, I was about to tell you superposition in second class, but I'm just gonna give you a small introduction to what superposition is, because my friend Wade already asked, and that is a genuine concern, because this will help you in understanding basically gravitational field and doing questions like these. Let's just see, yeah, surface. Yeah, that was at the surface. So basically you have something like this. You have a sphere, and suppose there is a hole in somewhere, and you have to calculate gravitational point at this. So basically what you're gonna do is you're gonna calculate what will be the gravitational field at this point, right? What will be the gravitational field if the sphere was full? That means if it does not have cavity, and then you're gonna and then you're gonna add what will be the gravitational field when this cavity is introduced, and this cavity will have mass minus m. Suppose uh, this whole thing has mass basically 4m, right? And this has you remove the cavity of mass m, so basically this will have minus m. So that will be the superposition, and the electric field will be some vector forces in the middle. So let me just introduce you something like this. So what will happen is that this will be suppose the gravitational field is a, let me just use my eraser. No, yeah. Suppose you have suppose the gravitational field of whole thing. Suppose the sphere this does not exist. Suppose the gravitational field comes out to be, let's say, x, right? And this the gravitational field due to this thing will come out to be, suppose we're talking about something over here, this point, right? We're talking about this point which is at distance r or something like that. That comes out to be due to this if it has had mass, comes out to be by, right? So the total gravitational field, so the total gravitational force will be the vector sum. That means this will be this whole thing will be considered plus x because it has mass, and it does not have mass. That means it will considered as minus y. So basically you're going to subtract this the force. Yeah, basically subtract the force from the total force which might be applicable to the object. So that is what happens when we talk about this thing, superposition. Sorry. Yeah. So this is our superposition, concept of superposition, and let's see. Yeah, let's move on because we do not have very much time left. We have okay, okay. Let's see. Yeah. So what happens is that this sphere will also apply, of course. Okay, sir. Okay. No, I'm gonna before moving on, let me tell you. If this sphere did exist and it will apply a force called y. Suppose a force called y, then the total sum of the force at this point will be x. But this will have while doing question we take this thing to be minus y, right? So this will have minus y. So the total force will come out to be x minus y. That is superposition. That means you can impose forces upon each other, but they will just be vector sum. You can add them as you like. So that's what superposition means. Suppose I just give you one. Okay, let me just use my stopwatch and giving you 1 more minute. I'm gonna explain it one more thing in 1 more minute so that you would get a little bit idea of what is happening without wasting any further time. Yeah, let's explain it to you. Suppose there are two objects, right? Object A and object B, right? They are distance x, right? And then there's this point called there's this point called, let's say, point A or something like that, and it is at angle theta or something, right? So this will apply a force called F1, and this will apply a force called F2. What superposition means is that basically you can solve, basically add these forces as a vector sum. So F1, suppose F2, and then this will be vector. So the total force is the F net, that will be equal to F1 plus F2. That will be superposition. And when you deal with hollow objects, you deal with minus mass. You deal with negative mass. By the way, negative mass does not exist, but you deal with it for convenience. That is how we solve JEE advanced questions. All right. This has been wonderful, and let's move on. By the way, we do free classes regularly, and on our YouTube channel, of course, we are available to everyone. YouTube is a great platform to perform, to have classes and to talk basically. So you can join us if you subscribe us, and be sure to follow us for more updates. And let's move on to talk about variation in acceleration due to gravity, right? So this is one of the favorite topic. This is one of my favorite topic. This is quite easy to understand, but the formula is not as beautiful as it was with this, right? This is a beautiful formula. This thing is a beautiful formula, but the formula for this will not be that beautiful. I'm just telling you. But it will come in handy. You might derive it as you like. So let's move on and let's see what is happening. Okay, sir. Now I got it. Amazing, 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 amazing. So suppose we have Earth, right? And this is angle theta, right? And this is a radius r, and this is a. Suppose. So suppose now tell me at the point this. Suppose this point is called point A. At point A, what will happen at point A? If you stand at point A, you will experience two forces because Earth is rotating, right? You might have I believe you already must have already done rotation. So point the force will be F1. They will have two forces which will be applied to them, and F2. Now what will be F1 and F2? So that will be let me just write it down. Why waste any further time giving variables? So that will be omega square A, right? A will be the distance to the center of rotation, of course, and this force will be mg. And if this is theta, then we can drop a perpendicular over here, right? And this will be theta, this will be 90 minus theta, right? So this will be 90 minus theta, 90 minus theta, and this will be 90. Total angle between them will be 90 plus 90 minus theta. That will be 180 minus theta. Of course, we are not dealing with degrees, we're dealing with radians, so it will be pi minus theta. I just use degree to tell you what happens. So let's remove it. So the angle between them will be pi minus theta, right? So this will be the angle between these two vectors. Now we're going to use a vector sum to just add them as we do. So what will be the vector sum between the force net? So the total force applicable on the object will be, basically, let's find out the acceleration, because I don't think the mass matters that much in this scenario, and it does not. Believe me, it does not. So how about we just find the acceleration? Instead of using F, we can use A, right? And instead of using m omega square A and mg, we can use omega square A and g. Now, what is A? A is, if this is theta, then this will also be theta. Then this will be A. So A is equals to RR cos theta, right? So this will be omega square R cos theta. Pretty interesting. Hey, Charlie, do you have something to ask? If you have, then that would be perfect. I would be happy to answer you. So we have omega square A is equal to omega square R cos theta, G, and this is G. So total acceleration, that means G dash, shall be equal to the sum of acceleration, because acceleration is also a vector. Remember, acceleration is also a vector. So we're gonna use a vector addition to just sum all the vectors up. That will be omega square, omega 4 R4 cos, basically, yeah, cos square theta plus 2 G omega square A, that is R cos theta, and what will be and into cos pi minus theta, right? Okay. What will be cos pi minus theta? What's cos pi minus theta? Remember what you have studied in trigonometry, in maths, right? Because everything is interlinked. Cos pi minus theta shall be equal to minus cos theta. Minus cos theta. So into minus cos theta, basically, that's what they're saying. So this is our equation. Now suppose we take G common, right? So G dash shall be equal to G, suppose we take G square common inside. So this will be equal to, like, bear with me, because this is gonna get a little bit tricky and messy. I know, man, I know. It's a little bit tricky and messy. Minus cos theta, exactly, my dear friend. Omega square R cos theta. Just bear with me what I write. I'm gonna explain everything to you. If you have any questions regarding it, I took G common minus. All right, I'm gonna remove this so that I could write. Okay. So this will be this, and this will be okay. And what will be this thing? If you take G square common, again, omega square R by G minus, okay, this will be minus 2 omega square R by G cos theta. Cos square theta, of course, cos square theta. And of course, let me just remove this, because this will be counterproductive to our equation. So this whole thing will be our answer. Basically, this is the equation, right? I told you it will not be beautiful. So can we just learn the process exactly? Exactly. I mean, can we just learn the result rather than a proper process? I would rather say, please learn the process too, because in my case, I learned the process, and if I need to, if I ever forget the formula, which you will forget it, believe me, you will forget it, and no one will be able to remember. I mean, this such a large formula if you are studying for JEE Advanced. So if I forget a formula, then I will just derive it. It will take only 2 minutes because I'm deriving it. That's why it's taking you too long. But if you are in my case, you will, if you are giving the exam, then you will derive it in basically 1 minute. I'm deriving it in so much time because I wanted to understand. Please understand the process rather than the result. Result is not more important than the process, right? Journey is more important than the destination. That's why we always say the formula is quite messy. Right? It's not as beautiful as one might expect it to be. So let's just this is the formula, and let's see. Let me remove this thing uh, because I want to explain you to some scenario which happens. The class has maybe surpassed its limit, but no worries about that. We aren't going anywhere. I am here for you, my student, my brother, assistants. Let's go. So if we are at pole, at if we are at equator, basically what happens at the equator, theta equals 0, right? Theta equals 0. So if theta equals 0, then g dash will come out to be g. Believe me, I have memorized this result because 1 minus omega square r by g. That's just it. Why? You can also put the put theta as 0 here, or you can do something like that. If you put theta as 0 here, this will give you 1 minus omega square r by g whole square, right? Because this is minus 2 omega square r and this cos square theta, right? So this will be this thing basically, and let's see. Yeah, if yeah, this will be, and you can also do something like this. Suppose this is the axis, and if you are on equator, then omega square a will point towards here, and g will point towards center, right? So you will be at exactly opposite directions, so you don't have to worry about anything at equator, because you will not even need to go into this formula, this whole under that kind of thing. And if you are at poles, at which theta equals pi by 2. So this is pretty interesting. G dash will be equal to put theta as pi by 2. This will be 0. This will be 0. G dash equals G. This is our result. This is our result, and this is what we get from this. Let's move on to another topic. Basically, I think we have covered all the topics which we need to cover for today's class, but we are do examples. Let's move on to example 1, right? Example 1. If the earth is basically if the earth is 1/4, sorry, if the earth is 1/4 of its present distance from the sun, the duration of the year will be changed to 2. So I'm not gonna do the questions for you because these are for your own practice, but I'm gonna tell you what's gonna happen. So what is time? What will be the duration? Time, that is a time will be distance, basically basically the radius upon basically the circumference upon velocity, that is time, right? Circumference upon velocity. So let me just write down the circumference, that means 2 pi r, 2 pi r, let's say, yeah, r upon velocity. Velocity can be found out by using the mv square by r formula. So mv square by r. So this is, we're talking about earth, right? So that's why we're gonna have capital M, v square by r shall be equal to mg, basically, not mg, basically g capital M mass of the sun, which will be, let's say, ms, right, upon r square, right? So this will cancel out, and you can find out the v as you can find out the v, basically gm by r. Okay, I'm just telling you how to do it. Basically gms by r, you can find the v, how it depends on the velocity, how the velocity depends upon r, and then you can put it over here and get the answer. This will be pretty straightforward, nothing to worry about. I believe you might have already done it, right? So if you still need to ask anything, just feel free. I will tell you everything. But let's move on. I don't want to spoon feed you into doing everything. Example 2, the height at which the acceleration due to gravity becomes g by 9. Yeah. Yeah. We. Yeah, of course. Exactly. So great, handwriting. Amazing. The height at which, okay, the height, let's move on. Let's move on fast. And if you need to ask anything, just feel free, Meherkali. I would love to answer it. The height at which the acceleration due to gravity becomes g by 9, where the, okay, you know what g is, you know everything. In terms of r, the radius of earth is, so what we have done about acceleration due to gravity above the surface of earth, g dash equal to g r above 1 r plus s square. Let's write it down. Let's write down g dash equals g r upon r plus h square, right? So g dash shall be equal to g by 9. G by 9, right? So this will cancel out basically. Okay, and we're gonna inverse this. 9 shall be equal to r plus h upon r square, right? Basically take under root on both sides, and if you're gonna ignore the negative, because of course distance cannot be negative, right? And square of distance cannot be negative. One day it will happen. Yeah, it will happen. It will happen. One day it will happen. So 3 is equal to 1 plus h by r. Question is not visible. It's too small. Yeah. I'm gonna explain it to you. So they are asking the height at which acceleration due to gravity becomes g by 9. So they are asking you h at which, just keep this in mind, at which g dash becomes g by 9. We're talking about height. So that is the question, right? In terms of radius, in terms of r. So basically, what they're asking, what will be the height? Nothing else. Okay. Okay. If you have anything to add, then that will be good. And Zaid Pathan, thank you for joining us, by the way. Okay. So h by r shall be equal to root 2 and h equal to 2r. Answer is solved, by the way. So you can try this question, and you might have this question in your mathematics practice materials, which you might do in your NCRT basically. By the way, NCRT Exemplar is a great book. I would recommend you try it. I would recommend you use it every time, because they will solidify your concepts. Move on to another example. Example 3. A body weighs 200 Newton on Earth. How much will it weigh halfway down to the center of Earth? Nothing much. They're asking that. Suppose they're asking that m mg. They're saying that mg equals 200, h equals 2 r. Amazing. Exactly. That's the answer. That is the answer. Great. They're saying that mg equals 200, right? So they're asking, first of all, they want us to find out the g dash at the center of Earth at the halfway. Well, g dash at halfway would be g 1 minus d by r, right? What is d? Half. That means g dash shall be equal to g by g 1 minus 1 by 2. G dash shall be equal to g by 2. HC Verma is great. HC Verma is great. I have done it. It's amazing book. If you want to get into IIT Delhi, right? IIT Delhi, by the way. So you only need to do HC Verma, Erudov, and That's it. By the way, don't try Aerodove. If you are not that confident, don't try Aerodove. It will waste your time. It's not a book for basically students. It's a book for scholars. I would like to say that. So first, let's complete this question. So therefore, I want us to find the new weight, which is mg dash, which shall be equal to mg by 2, which shall be equal to 100 Newton, right? So we have the answer here. So that's it for today's class, right? Before moving on, let me just tell you a few things about us, about what we do, and who I am, and why am I teaching you here. So let's see. So we at Altedemy, I'm gonna answer your questions after this. By the way, don't worry, I am here for you. So at Alternate, we our courses offers 90 plus classes, which each class being 1.5 hours long. So that will be no problem for you. We also offer homework, and we will also check your homework, by the way. So at the end of each class, we also offer homework, and we have a convenient educational platform. We have syllabus. We will consider complete every syllabus from uh, the starting point to the finishing point. We have flipped classroom method. I'm gonna explain what this means. Right, I'm gonna explain what this means in the next slide. We have doubt solving practices, of course. I'm gonna solve it out if you have anything like I did right now, by the way. And let's move on. So what do we mean by flipped classroom method? Right. So that it is like something like this. We will provide you with theory before the class and study material before the class, and then you will come to a webinar, right? Being prepared, knowing half the things, and then we're gonna give you homework, and then we're gonna check your homework. By the way, this is the method which is used in Harvard and MIT, like top universities in the world. Even IIT they need to use this. So this method ensures that you know your topic beforehand and you have higher interest. I remember there was a professor of mine, Samir Jan. Yeah, he was a professor of mine in basically the first year, and he tried this method. So basically, most of the students in his class never got. I think 90% of the students of his class got a grade above than A. So in college, getting a grade above than A, that is a big thing. You and IIT, not really actually. I did not get my satisfied branch there, to be honest. The branch which I was getting was not that satisfactory. And if I was getting a satisfactory branch, then that was at IIT's far away, which is not the top five. So I was not basically an IIT. So, but I wanted to be one, right? That's why I will tell you what I did to basically score. I had a great score, by the way, in mains. Advanced was not so fortunate for me. So basically, it will turn out great for you. Don't worry. I mean, it's all about luck in the exam, and it's all about what you practice. That's it. So this is theory, and we provide you theory and study material, and then we provide you webinar, and we will provide you homework, which we will check, of course. That's what we will offer. And these are the courses which we offer, by the way, light, smart, and professional, to be honest. So light is most basic course in which we have live classes, structured courses and PDF, live tests, and physical notes. These are all the things which you will get in light. Because we know that every students come from different financial background, and we offer our courses and we offer our services to everyone regardless of the financial background. So, but if you come from a well-off financial background, you can choose smart courses which offer a lot more things, which is 1:1 mentorship. That means some faculty will be your mentor, and will tell you how to cope with stress. They have live doubt solving, mock tests. By the way, mock tests are quite important. Believe me on that. Mock tests are amazing. I remember, like in the mock test which I had given before doing IIT, before giving IIT JEE, I had received around 315 marks in JEE Mains, right? And that basically that boosted my confidence, so that I was able to score more than around 250 marks. Yeah, I don't know the marks exactly, but it was more than 250, in the range of 253 or something like that, right? But it's also a great score back then, because I never expected that. So if you have great score in mock test, you will have great score in real life exams too. It will give you a feel of what's happening, right? So we are of course providing mock tests. Mock tests are the most important part of your journey, because if you do not test yourself, then you do not know where you stand amongst others. So the smart course provides you mock tests, homework via Telegram, or no, we will provide you homework on this YouTube platform. So basically on our website altedemy.com, we have We have everything which is going on. So there are slides in which there is homework, and and then there's a homework solution. Yeah, platform basically. So we have mock tests. Of course, I was telling you about mock tests. Please be sure to take tests regularly. Like it's a personal advice from me. So tests are very, very important. And then if you choose professional, if you want to add an extra edge, then you could have additional special courses for on additional topics. For example, some topics will be covered in depth detail, so that they would not be a hassle to you. So that's Altedemy for you. That's our plans for you, and we love you guys very much. And it's an honor teaching you. So if there's anything you need to ask, then feel free. Go ahead, ask me anything. I will give you around 3 minutes to ask me anything you like. Right? Yeah. Yeah. Let's see. Okay. Okay. Yep. Let's see. If you have anything to ask, feel free to go ahead, and I will give you the techniques on how to solve this. I will give you a technique on how to crack IIT JEE. Of course, by the way, I was able to crack IIT exam. I did not have enough, not even great marks in maths, but on physics, I can assure you, you are in great hands. Don't worry. So if you have anything to ask me, yeah, feel free. It would be amazing. And how is your life going, by the way? Tell me, how is everything? Are you fine? How's the preparation going? And are you coping? How are you coping with the co-op with the stress? Sorry. Okay. Okay. I like that word, by the way. So let's see. I have around 40 seconds left before I leave, and let's see. Uh, 30 seconds left. Right. If you need to ask anything, go ahead, or maybe then maybe I can say goodbye. If not, then I believe this is goodbye for us. I will be hosting another webinar on Monday, and then another one on Wednesday. So that will be Gravitation lesson 2 and 3. This is not the only one, don't worry. I will give you the 2 and 3 for free, of course. So be sure to follow us on Telegram, by the way, if you wanna use that, right? How to solve tough question of HC Verma. Now the real questions appear. So how to solve a tough question of HC Verma? Basically, tough question of HC Verma will uh, will challenge every concept which you have. They will test every concept which you have of the subject. So they are most like Erodo, but try doing one thing. Uh, Basically, tough questions are not that tough if you have your basics correct. So try to think of, first of all, visualize a problem. That means have a visualization about what is happening. So visualize everything. Let's make a diagram about what is happening and how an object is falling. Make a free body diagram if it's about physical, if it's about rotation and all, and think about what will happen, which type of forces will appear. Did we need to read the theory again and again? Yes, you need to read the theory again and again, because theory is very necessary for you to understand what is going on. And I think after 3 months, after 3 months or so, just read the chapters which you have studied 3 months earlier, right? And thank you for coming, by the way. I believe that's it for now. So do your revision, study harder, and I will see you in the next class. Till then, have a nice day and goodbye. It was nice teaching you.